Hello and welcome to Module 16, Lesson 2, which is Orogeny, which means mountain building. All right, so just a reminder, a review, an island arc is islands that form, they're volcanic chains. They happen to be forming from underwater and moving above, and so they're referred to as island arcs. We have something similar, but on land, and that would be with Mount Shasta, Lassen, and so on, except for obviously it's not underwater, so they're not islands. All right, so orogeny is just any kind of mountain building. So that could be volcanoes, it could be mountain ranges. So generally, mountains aren't formed all by themselves, they're formed in ranges. So anytime that occurs, it's called orogeny. So here's where we have most of our mountain belts. So you can see they follow the plate boundaries. So you can see here we've got in North America our Rocky Mountains, our coastal range. We've also got some other smaller ranges like the Sierra Nevadas and things like that. But if we notice, the majority are somewhere near plate boundaries, and sometimes they aren't. Like for example, right here, this is mainly due to it being an older mountain belt that formed when the Indian Australia plate happened to be connected to South American plate. But for the most part, all of our mountains occur where plate boundaries are at least close. All right, so we've got ocean-ocean convergence. So when oceans collide, one of the ocean plates is a little bit more dense, so it sinks, and that's what forms this island arc. So this would be a mountain range, and so Japan's a great example of this, that we have a bunch of islands, which make up the Japanese islands, which are basically just volcanoes. And then they mostly are made of basalt, so they're coming from the ocean bottom. They do have some andesitic magmas, so sometimes, especially in the Philippines, we see some andesitic, so some more explosive eruptions. But most of them are going to be dark colored. So a lot of islands have really dark colored rocks because it forms from the ocean bottom. All right, and then when we have ocean and continent plates colliding, we get really complicated mountain belts. So we get really vast, large mountain belts like we have in North America. So all along the west, we have a lot of complicated, complex mountain ranges because of that convergence. All right, so here is that. So we've got the ocean plate colliding, the continental plate here, and then we get multiple layers of mountains. So we've got our volcanic mountains. So if we're thinking of California, this would be Lassen, Shasta, and then up through Oregon and Washington. And then we've got our coastal range here, and that's just because of this uplift, this pushing. And then we've got the Sierra Nevadas over here, and then way over here we have the Rocky Mountains. So it becomes very complex rather than just the island chain. All right, so that compression just causes that squeezing and buckling. So if you look around here in this area, we have a lot of metamorphic rock. If you go, like I mentioned, to Shasta or Whiskeytown, you'll see the folding. So the layers will actually be folded and bent, and that's just because of that convergence, that squeezing together. So a lot of metamorphic rocks. And then the continents have really low density, so they're much less dense, so they tend to float on top, whereas the ocean crust goes under when those two plates collide, and that's because of density. All right, it's continental convergence. So remember, here we don't have, both plates are very light, very less dense than the other, and so they're going to push up together. And so when they push up together, notice how these are forming faults. So remember how we have our hanging walls and footwalls. So we do see a lot of faulting here. And then we also get uplift. So both of these are uplifting, and they form very tall mountains like the Himalaya mountains. And so Mount Everest is part of something like this. And we've got the Indian plate here, we've got the Eurasian plate here, and then together they're pushing up and forming those really tall mountains. All right, so what we also see is marine sediment. So at one point, India was pushing ocean up before it collided because it used to be separate. So those ocean marine sediments, so marine fossils, are found really high up in the Himalaya mountains. So it's kind of funny, our tallest peaks on Earth have marine sediment and marine layers because they used to be on the ocean bottom and they've been shoved all the way up. We find the same thing here. So I mentioned at Shasta College, there's a big area of fossilized sea creatures, so like shelled organisms, brachiopods and things. And so those are found over by Shasta College, even though it's really far away from the ocean bottom. And so those have all been pushed up because of that convergence with the Pacific plate, the Juan de Fuca plate, and the North American plate. And that's it. Oh, no, never mind. Oh, yeah, that is it. Yep. All right, I will see you guys next time.